All right, so here we are in Lithosphere Natural Hazards 2.2.3. So key question 2 in the Lithosphere section 3, where we're going to be talking about types of volcanoes. Now you guys did a great job on your project that you've had so far, but I just wanted to go over some of the information that's on the blog in case you had any clarification that you needed. Please watch this video. This video is really cool at introducing you to volcanoes and how they work and all that kind of stuff. All right, so then we're going to go straight into this website, which is the U.S. Geological Society on types of volcanoes. So I just want to show you what we've got going on in here. First up, the first simplest type of volcano is the cinder cone volcano. The cinder cone volcano is going to be built from particles and blobs of congealed lava ejected from a single vent. As the gas-charged lava is blown violently into the air, it breaks into small fragments. I mean, you guys could read that. So basically what you've got here is your normal type of volcano that you would normally probably think of. It's just straight up going to be layers of magma. You've got a central vent going up the middle, rock fragments, and a crater in the top. So most cinder cones do have that crater at the summit. Yeah. All right. So you can see there's a cinder cone in there. Let's talk about the next type of volcano, which is a composite volcano, also known as a stratovolcano because of the stratified layers that you can see that go up that middle part. Does not usually have a giant crater at the top until, a big explosion. But you'll have vents, one big vent and then smaller vents going out the side as well. So these are going to be your steep ones. These are going to be your really tall ones. Mount Fuji is one. Mount St. Helens. These are different ones that we've talked about in the class with the projects. Most composite volcanoes will have a crater, but it's not going to be the giant, or not. It's not going to be like the big crater like in that cinder cone. Lava is either going to flow through breaks in the crater wall or a fissure from the flanks of the cone. So kind of just like keep filling up the sides of that, building that thing up. Okay. And you can see a cool thing that happens is that after it blows up, after it because usually these things are going to have, these are going to be the ones with the big explosion. So the entire top can go off, and then you can get giant craters that don't even look like they're on top of a volcano anymore because it just like leaves a depression in the earth, and can form awesome craters with lakes that are made from these. And these giant craters that are made after an explosion like that depression is called a caldera. So the caldera is the depression form for that. So you can see here the evolution of a composite volcano. Magma rising up erupts at the Earth's surface. Then it continues over hundreds of years. The cone is built higher and higher and higher because more and more lava is falling over the side. And then eventually the volcanic activity will cease, erosion will destroy the cone, and it will become a caldera. All right, shield volcanoes. So shield volcanoes, think about, the most famous shield Captain America shield, right? It's just basically non-steep, gentle slope type of volcano, and that's what we're talking about here. This will have less viscous lava. That means it's going to be not as thick, and it's basically going to be runny, and it's going to kind of continuously come out. So fluid lava flows, flow after flow pours out in all directions from the central summit, basically making this shield-type volcano. These are not usually going to be super explosive, but they are going to be active continuously. So Mauna Loa, Anala in Hawaii, and Kilauea are both shield volcanoes. A lot of the ones in Hawaii are. All right. Lava dome is going to be basically going to be viscous lava that continuously flows, unlike the shield volcano, where it's non-viscous, so viscous resistant to flow, so it's going to be thick stuff. And so it's going to be basically, so they're not going to flow far away and make that shield. It's going to keep piling up, and it will make a lava dome type of volcano. And these can be like pretty high, so it's pretty cool. Yeah, there we go. All right, so let's look at the next type, and that's the type of explosions. And this is important when we look at this. This is from San Diego State University. We're only going to look at basically 3 types, but I wanted to tell you why these 3 types exist. So we've got non-explosive and explosive and intermediate. All right, so many eruptions are relatively quiet, characterized by calm, non-violent lava flows. Other eruptions are highly explosive. And all this stuff coming out, that's called tephra, okay? So it's all like all these things that are coming out. Sometimes they even call them bombs and stuff that come out of the volcano when it explodes. That stuff is called tephra, all right? Whether or not an eruption falls into an either explosive or non-explosive or intermediate depends really on 3 different factors, all right? So it's going to depend on the viscosity, the resistance to flow. Remember, the higher viscous it is, the more resistant to flow it is, like syrup, all right? So syrup is viscous compared to water. It resists flow compared to water, all right? Temperature, that's going to definitely play into this. And the amount of dissolved gases that are in the magma are all going to play into how explosive this is. Think about this, right? So if you've got this thick liquid like syrup, right, and you shove a lot of gases into it, it's going to explode. However, if you have water, which isn't viscous at all, and you bubble gas into it, it's just going to escape off the surface. So the more thick and the more gases you have inside is a recipe for explosivity. All right? And really, it's going to be a lot of your magma, the silica dioxide content. How much silica dioxide is in there. And you can read all about the different rock types in there, but just know that your magma and the viscosity is going to depend on the silica content. The higher silica we've got, and we go from 50 to 70, the way more viscous it is. All right? So you can read all about that up there. I'm not going to go through everything in this, but I do want to go down to here. So you got the silica content relating to the viscosity. Silica on the left, viscosity in the middle, right? So silica dioxide, if it's at about 50%, if 50% of your magma is made of silica dioxide, that's going to mean it's actually it flows pretty good. The viscosity is low. The gas content, therefore, will be low because it can't trap as much gas. Therefore, you usually will have non-explosive. So about 50% silica, non-viscous, non-explosive. 60%, we got more viscosity in there, more resistance to flow. You're going to have intermediate viscosity, therefore intermediate gas content because it can trap more, and an intermediate eruption type. And finally, 70% silica dioxide, we call that felsic, all right? That 50% is mafic. Felsic is going to be thick. It's going to take a lot of gas in because it's so thick, and therefore it's going to become explosive type of volcano. So those are basically your different types of volcanoes. There's a lot of other good information on the San Diego State main site. You can see more stuff on the left-hand side about the different types of volcanoes, the different types of eruption products like tephra, pyroclastic flows, lahars. Let's get into that just a little bit before we move on. All right, you can see pyroclastic flows are going to be that's going to be the stuff that comes out. You can see the big smokestacks. Pyro meaning fire. Pyroclastic flows are going to be basically giant eruptions. And the semi-solid fragments, hot expanding gases, and it's going to be all that kind of stuff that comes out. We've also got lahars, and we talked about that a little bit in the presentation. Lahars are going to be mud flows. So yes, you're going to have lava flows go down. We all know about lava flows. That's when the lava comes out of the volcano. But mud flows are going to be basically where you have enough shaking from the volcano that you trigger a mudslide off the sides of the volcano. And basically that can be even worse than a lava flow. And please just read about the rest of those on there. And so that's pretty much all we need to know on this section.